Myself, I am Saranya, working as an assistant professor in the department of CSE AIML in MLR Institute of Technology. Today, I am going to discuss the topic about encryption and AES. AES is nothing but an advanced encryption standard algorithm, which is useful for encryption and decryption process. So, coming to the first slide, we need to know about the what is overview of discussing about the topics. Firstly, what is encryption? And next, types of encryption and what is meant by AES and working of AES algorithm, how it is in the working process and application of AES. So how many types of applications we are going to use in the AES algorithm. Coming to the next one, what is meant by encryption process? As we know already, we have discussed in the previous slide of encryption is nothing but it is a piece of information which is converted to the ciphertext. It is nothing but an plain text is converted into the ciphertext. Plain text is nothing but an readable format. Ciphertext is nothing but an unreadable format. That's what we have discussed in the previous slide. So, piece of information which is converted to ciphertext. So, it is mainly important to protect your consumer information or any other emails which is sensitive data from unauthorized access as well as communication networks. So, all over the information which is getting the information to particular networks only. So, basically we are going to hide the particular information from communication networks. We are having the types of encryption process divided into the 3 types. So, first one is symmetric encryption process and also asymmetric key encryption process. So, basically types of encryption we have divided into the 2 types of encryption process. One is symmetric key encryption and another one is asymmetric key encryption. So, coming to the next slide, we are going to see about the topic of symmetric key encryption. This is the first type of encryption process. So, in the encryption process, we are using to see about the same key for both encryption and decryption process. We are using the same key for encryption and decryption process in the symmetric key encryption because it uses the same key and can be more cost effective for the security purposes. That is the main benefit of the symmetric key encryption. Let's see one example of symmetric key example. So, this is the plain text and this is the ciphertext and conversion of getting the original plain text. So, firstly, we should see about the plain text, how it is going to run the process. In symmetric key encryption, the secret key is encryption process and secret key is for decryption process. And we are using here same key as for the ciphertext process. How it is going to convert in the symmetric encryption process? The plain text is converted into the ciphertext and only one key is used for the same encryption process and also the decryption process. Here we are using the encryption and decryption process and main is the secret key. The key is for used to between the purposes of encryption and decryption process. See here, overall which is converted the plain text to ciphertext, we are getting the including of all the characters and some of the numerical values of the inside output. But the input was plain text and output was ciphertext. But using the same keys. Same keys for both encryption and decryption process. Coming to the next second type is asymmetric key encryption. In asymmetric key encryption, we are using the 2 separate keys for both encryption process and again decryption process. One is a public key and another one is private key. Once a public key is used for the encrypt the data and private key is used for the decryption of the data. So, it uses the same key for both the encryption and decryption process. So, this private key is only accessible to the users with only the authorized access only. It is not possible to given to the users of unauthorized access. Only the private key is given to the only of authorized access. So, let us see an example of asymmetric encryption. For example, here a sender and here an receiver. So the basically communication going between the sender and the receiver. Whatever it is a plain text data and it is a decrypted plain text data. Means it is the original plain text data and it is the decrypted plain text data. Middle here it is an cipher data. So this is the cipher data is nothing but an unreadable format, right? This is an unreadable format of information. So this is the unreadable format of information means whatever the sender is going to send the message to the receiver, it is unable to read the message. That is what ciphertext format. And we are using for the one way of encrypt the process for public key and another one is private key. So whatever they're going to send the information from sender to the receiver, they are using with the help of public key and with the private key. Okay. Next one is encryption algorithms. We are having the three types of encryption algorithms. Three type of algorithms. So first one is AES, RSA and DES. These are the three types of encryption algorithms. AES is nothing but an advanced encryption standard algorithm. RSA is nothing but an reversed Shamir-Adleman algorithm. DES is nothing but an data encryption standards. So whatever here using the advanced encryption standards for the and also we are using the bits of same in the data encryption standard of DES. So coming to the next one, first one encryption algorithm is AES. AES is nothing but a stands for Advanced Encryption Standard Algorithm. So, what is meant by AES? Firstly, we should know what is meant by AES. It is nothing but an highly trusted encryption algorithm used to secure data by converting into an unreadable format with the proper one key. Key format of using highly trusted encryption algorithm used to secure data by converting it to an unreadable format. It means whatever we are using the encryption algorithm, main purpose is to secure our data into an unreadable format, not in an readable format, in an unreadable format. So here the unreadable format is nothing but an ciphertext. So plain text is nothing but a readable. Here unreadable is nothing but an ciphertext. So in other words, we can say that trusted encryption algorithm you can also use it to secure our data by converting it into an ciphertext. So next, basically we can use this algorithm into an 128 bits, 192 bits or 256 bits to provide the strong protection from an unauthorized access. So we can use the bit length of the key lengths to provide the strong protection between the among unauthorized access. So main points to remember, it is nothing but an AES is a block cipher method and we can using the key length of 128, 192 and 256 bits. So it can encrypt the data in the blocks of each bit consists of 128 key length. The next, that means it takes 128 bits as an input and output also getting as same 128 bits, which is converting the plain text after the original. It also gets the same 128 bits output of encrypted ciphertext. So whatever we are going to convert, the plain text is converted into the ciphertext. We are using the same bit of 128 is nothing but a plain text and 128 bits of getting us output of ciphertext. Then coming to the next slide, working as the cipher. What is the overall working of the cipher of AES? So here we can see the overall experience of working of the cipher, how it is going to work about the AES. So basically it performs the operation on bytes of data rather than in bits. Means we are going to see any of key length of bits 128, 192 and 256 bits. Rather than these bits, we can operation on bytes of data. So the block size is 128 bits. The cipher process also taking as 128 bits or 16 bytes of the input data. Already we have discussed in the previous slide. Here 128 bits is taken as the plain text and also output also getting as an 128 bits of encrypted ciphertext. So this ciphertext whatever is going to convert is the same length of the cipher process 128 bits is going to as input data at a time. Means whatever you are going to take the input data from the plain text, the output is also getting the ciphertext process of same 128 bits. Here the number of rounds in the AES will be to perform the operations on the data. We are going to see as an 10 rounds, 12 rounds or 14 rounds. This 10, 12, 14 rounds, how many rounds it is possible to? Each length is 10 rounds, means we can take the key size of 128 bits. If there is an 12 rounds, we can take the key length of 192 bits, and if the key length is number of rounds is 14, we can take as an 256 bits. So this 3 for 10 for 28, 12 for 192 and 14 for 256 bits. Then basically we need to know creation of the round keys of the encryption process. So in AES we are going to see as an encryption method and also decryption method. Encryption method and decryption method. Encryption method is nothing but an original one. So decryption method is nothing but an which is converted of original plain text. So see here, the encryption process, firstly we need to know about the encryption process. The first one is encryption and second one is decryption process. The first one is encryption process, how we are going to create the some round of key based on the length and also the number of bits. So here the schedule algorithm, it calculates all the round keys from the various key rounds. So basically we are going to initialize key used to create and many different round keys which is used for the round of the encryption process. So basically we are going to see all the round keys are how it performs from the round of the encryption process. So basically it consists of 4 steps. One is subbytes, shift rows, mix columns and also add round key. Based on this 4 process, how we are going to perform the working cipher of AES algorithm. Coming to the next slide. So firstly, plain text. We are taking as plain text of 128 bits. And we are here performing the pre-round transformation. Pre-round transformation is nothing but an each round how it is going to perform. By each round it is going to repeat the same process of checking of each length. Each length is going to repeat the process. So first one is pre-round transformation. Whatever it is going to take the length of all rounds, it is basically of pre-round transformation. In the pre-round transformation, we are having the n number of rounds. So round 1 to round 10 or round 1 to round 20, number of round 1, round 2 and so on up to round n process. So whatever you are going to converting of original one, it is converted as an converted plain text. So this is the converted process of ciphertext. So how many bits we are going to take and how many rounds we are going to perform, we have to check while working of the AES algorithm. This is the key expansion method. Why this key expansion method? We are using the number of keys from starting any round while we are performing. We need to start with the key length of K0 up to K0 to Kn process. For example, K0, K1, K2, K3 and so on Kn process. Means 0 length to Kn number of processes, we can use the number of keys and also the number of rounds. Then next, we should know, we already discussed in the previous slide of, there consist of 4 steps. One is subbytes, shift rows, mix columns and add round key. So this basically implements the substitution process. In this substitution process, we look up the table of S box. The substitution is known as S box in the AES. So that byte is never substituted by itself and also not substituted by the another byte. Means it cannot be substituted by itself and also should not be substituted by another byte, and also it takes the step of 16 byte 4 by 4 matrix like before. Means, for example, here R1, R2, R3 and so on, Rn bits, means these are all rounds. For each round it performs a key length of K0, K1, K2 and so on, Kn process. For this all processes, there will be a number of rows and number of keys. The next, shift rows. Here each row is shifted to a particular number of times. So for example, we can take first row is not shifted. If for example this one is not shifted, then next the second row is shifted to the ones to the left. Means whatever we are blocked of first one, we can use the second one to combine this second row. So once it is shifted to the left, it should not be again move to the next round or next key. Then next third round is shifted twice to the left. Like this process, we can see the third row, fourth row and fifth row up to how many rows we are going to perform in the AES. Means by basically taking off number of rounds. It may be 10, it may be 12 or it may be 20 rounds. The next one, mixed columns. Mixed columns by using as an matrix multiplication. So basically mixed columns is nothing but an matrix multiplication. By matrix multiplication, each position of the each byte in the column is changed as a result. By basically column is nothing but an result. So here we can see the result of the whole AES process. So this result can be skipped in the last round. Means we can skip in the last round of the AES. That's what they are saying of the mixed columns. So we can skip in the last round of the AES. So next one is add round keys. In this add round keys, the resultant output of the previous state is XOR related with the corresponding round key. So we are using here the XOR operation to perform the add round keys. And total here will be the 16 bytes are not considered as a grid but as an 128 bits of DID. How many bytes? 16 bytes and 128 bits. We can use the any number of bits or bytes. So after this all process, 128 bits of the encrypted data is given as an output. Means it is nothing but a plain text, and again it is nothing but an ciphertext. Means nothing but an converted of plain text. Converted of plain text. So as we seen in the previous slide, so whatever we are getting the 128 bits of whole plain text, and we are getting the output is also as ciphertext of 128 bits. The next one is already we have seen in the previous slide of encryption process. Encryption process. The next now decryption process. What is meant by the second type of the AES? We are going to perform only the two processes in the AES. One is encryption process and another one is decryption process. So second one is decryption process. In this decryption process, we can easily having an stages to opposite while we are performing of encryption process. So it is the quite different of conversion of AES. Already we have seen the encryption process. The encryption is quite opposite of the decryption process. So each 128 blocks can go through the 10 or 12 or 14 rounds. As we have seen the same 3 rounds of the before encryption process. So same we can perform in the decryption process also add round key while we are using the mixed columns or any shift rows, insert bits and inverse mixed columns. It is the quite opposite of the encryption process. As we have seen in the encryption process is mixed columns, sub bytes and shift rows. But here we are doing as an whole inverse process, means inverse process. So add round key and inverse mixed columns, shift rows and inverse sub bytes we can use the with the length of 10, 12, 14 rounds with the key length of any, but we need to get the 128 blocks of same plain text and ciphertext. We need to get the whole output of plaintext and ciphertext of only 128 bits, nothing but a 128 blocks. The next one, coming to the application of AES process. So in the AES process, we are having an first application is wireless security. So wireless security is nothing but an wireless in connecting networking, means such as, for example, Wi-Fi networks. Why we are using the Wi-Fi networks? To ensure data confidentiality. Data confidentiality is nothing but an only when having an access to the only particular authorized people only, not as an unauthorized people. So it prevents unauthorized access to ensure data confidentiality. The next one is database encryption formats. So in this database encryption formats, we can see the encrypt only sensitive data which is stored in the databases. So that is called as an database encryption formats. So it is basically what it protects: personal information and financial records. So this is the two process that is going to protect in the database encryption process. The next one is secure communication. Secure communication means such as internet communications or any emails, any instant messages or voice calls or video calls. This all the comes to the securing purposes. The messaging and voice, video calls, internet communications, these are all belongs to the securing purposes. How we are going to secure our information. So basically it is used in the protocol format. The next one is data storage. Data storage is nothing but an encrypt basically sensitive data. Whatever the information is going to hide in the saved in the hard drives or USB drives, any other storage media performance, it is basically encrypt sensitive data which is stored in the hard drives, USB and other storage media. Any storage media we can protect our information. So see here, the protecting it from unauthorized access in case of loss or theft. It may be loss condition or a theft condition. It may be comes to the data storage process. The next one is VPN, virtual private networks. This is the very most topic we have seen in the networks. So that is nothing but an virtual private networks. So this VPN protocols basically used to communicate between user devices and then remote sensor devices. So basically communication starts with an user and ends with an user. So the user devices and the remote server process can see in the virtual private networks. So this all applications comes to the AES formats. How many types of AES formats? That is applications of whole 5 formats, nothing but wireless security, database encryption formats, secure communication, data storage and VPNs. VPNs is basically used in the networking, that is used to user devices formats and remote server process. So in today's session, we have discussed with the topic of encryption, types of encryption, AES working cipher, this AES working cipher of encryption and decryption process. This is the original encryption. In decryption process, we have seen the converted of plain text, means original plain text process. The next one is application. In application process, we have seen the 5 applications of AES process. So in the next session, we are going to discuss about the topic of RSA algorithm. It stands for the reversed Shamir Adalton algorithm. Thank you.